Hi everyone, this is Doc Wisdom and today we will talk about hydrogeology and aquifer. But before, subscribe to my channel, share, and now enjoy this new video. As I said, today we will talk about hydrogeology. Obviously, I can't tell you everything about hydrogeology, also because I don't know everything about hydrogeology. It will be like a bit more than an introduction. Hydrogeology is the science that studies underground water. But before to talk about hydrogeology, maybe it's better if we talk about water. Water is a molecule formed by two atoms of hydrogen and one of oxygen. In hydrogeology, there are two big groups of water: atmospheric water and lithospheric water. Atmospheric water is contained in the atmosphere as vapor, liquid, or solid, like snow or hail. Lithospheric water is contained in lithosphere and is divided in groundwater, like rivers, lakes, and so on, and underground water. All of them are included in hydrological cycle. That is the mix of evaporation from lakes and sea, precipitation like snow or rain, and runoff. A lot of people think that underground water is in big reservoirs in rocks, like underground holes filled by water, but except few exceptions, like karst, it's not exactly like this. We can divide rocks in permeable and impermeable. Permeable rocks are named aquifer, from Latin aqua, means water, and fero, to bring. Permeability depends on porosity, that is the ratio between volume of the void and total volume. It can be primary, that is porosity formed during the settlement of the rock, like sand. Or it can be secondary, that it means that it forms after the deposition of the rock, like karst or lava. Or can be caused by tectonic phenomena, like faults. But not always a porous rock is permeable. If pores are not linked each other, water can't circulate. And a permeable rock not always can be an aquifer, because permeability can be so low that water can't circulate. Good aquifers are limestone or sand or lava. Bad aquifers are clay or very fine sand. Underground water is divided in hygroscopic water, that is water that surrounds grains of rocks. It can't be used and it is lost at 105 degrees Celsius. Pellicular water, it is a second layer around grains, can't be used as well, and it is lost for centrifugation. Capillary water, that is water that can be found in very small holes. It doesn't follow the gravity and is that water that maybe you saw in walls. Walls sometimes can have at the base a zone very humid. That is capillary water. And the last but not least, maybe is the most important, gravific water. It's called like this because it follows the gravity force and is the water that we can extract and use. Permeability is the speed of the water to cross rocks. It can be very high if voids are very big, or very low if voids are very small, like clay. It is measured in Darcy. 1 Darcy is 0.987 per 10 to -12 power meters squared. Basically, all rocks are permeable, but sometimes permeability is so low that they are considered impermeable. There are two kinds of permeability, for fissures and for pores. Permeability for pores is typical in porous rocks, loose or not, which contain many pores. Permeability for fissures is typical in compact and brittle rocks. When these holes are full or partially full of water, we have an aquifer. Basically, it's like a sponge. You can't see the water, but there is. In an ideal aquifer there is a zone called the Aeration Zone that is divided in Capillary Zone, where we can find capillary water, Transition Zone, and Evapotranspiration Zone. That is the zone subjected to evapotranspiration of plants. In these first three zones we have water, but we can't use it. Lower than capillary zone there is the water table or piezometric surface. This surface is the borderline between unsaturated zone and the saturated one. Lower than piezometric surface there is the saturated zone, full of gravific water. But to have an aquifer and to not lost all water, we need an impermeable surface that is lower than saturated zone. Piezometric surface can be stable only if the influx of water to the aquifer is more, or at least the same, to the outflow, but it can change depending on many things, like rain, season, or humans that use water. And obviously, if today it rains, we will not find this rain tomorrow or the day after, but maybe in 1 month or maybe more. It depends on the permeability of the lithology. Underground water is not still, but it moves. We can have two kinds of movements. Vertical, that can be downward if we have gravific water, or upward if we have capillary water. Movements can be also horizontal, that are movements that interest us a bit more. Water flows also underground if we have a slope or a gradient. This movement can be of two types, laminate or turbulent. When flow is turbulent, water is turbid, because it brings a lot of microparticles. We can recognize 2 or 3 kind of aquifers. Free aquifer, when all the points or piezometric surface is at atmospheric pressure. So we have a permeable part but unsaturated with capillary zone, transition zone, and evapotranspiration zone, and then lower a saturated part. Another kind of aquifer is called confined, and we have an impermeable lithology, a permeable and saturated lithology, and lower another impermeable lithology. So piezometric surface is not at atmospheric pressure, because there is the pressure of impermeable lithology, and the piezometric surface doesn't match with the border between saturated zone and unsaturated zone like before, but it's higher. Another kind of aquifer, but it's more like a particular kind of confined aquifer, is called Artesian Aquifer. An aquifer is defined like this when water, when it's intercepted, arrives higher than the ground level. The effect, it's like a fountain. Last two cases are under the law of communicating vessels. The saturated part of an aquifer can be also divided in two zones. The zone of regulatory reserves, that is the zone where there's more circulation of water, so water is less mineral because it's less in contact with rock, so better to use, because if new water arrives, where it will arrive? On the higher part, that is the part of regulatory reserves. So it's also water that we can use without danger, because considering seasonal hydric provision is water constantly replaced. And then lower we have geologic reserves. That is that part of the aquifer that, if used, can't be replaced considering seasonal hydric provision. And it is also water a bit worse because it's much more in contact with rock, so it is more mineral. So considering that if it is used, can't be replaced, should be preserved, but not always is like this. Water is very, very important, and it's not limitless, but can finish. According to UNESCO, the next world war will be for water. So please guys, don't waste water. So, if you like this new video, thumb up, leave a comment, share, subscribe to my channel and follow us on the Facebook page Learning Geology. Big ciao from Doc Wisdom. See you next time.